Okay, so in this presentation now, we're going to get to the nuts and bolts of how you actually start accessing and working with Aquarius data. Let me get my little pointer, and off we go. So again, the point of entry to all PODAAC resources is the web portal, okay? And the particular capabilities that we're going to be talking about in this presentation are FTP and a series of web services, including OPeNDAP and THREDDS and a set of PODAAC web services that have been developed for doing a range of things on data sets, querying data, subsetting data, and acquiring data, excuse me. So probably the simplest and everything that, something that everyone will be familiar with is FTP. You can simply use your web browser to go to our public FTP site, okay? It's an anonymous FTP site. Your browser automatically knows how to get into it, essentially. And then you'll see a series of directories. Things are organized by parameter. In this case, we're interested in salinity and density here, but there's also sea surface temperature and other parameters. Things are also organized by mission, so you can look for things for an Aquarius folder as well. So that's the first level. You can start drilling down sequentially through the hierarchy of folders and directories. And within the Aquarius sort of root level, you'll see that the data sets themselves are organized by level. So level 0 through level 3, okay? And in addition, there's a couple of directories where we maintain all the technical documentation that I talked about last week and that are referenced on the Aquarius mission page, in addition to the MATLAB and IDL reader software. Okay, so you can continue clicking through. So we are looking at level 3 now and the mapped. So you can see things are then organized by version. I just wanted to the current version, of course, is version 4 of the dataset. I just wanted to mention that since this slide has been produced, we have actually retired the version 2 and version 3 datasets. So if you were doing this interactively as I'm speaking, you would not see V2 and V3 listed anymore, okay? Those would occur in a quote-unquote retired subdirectory within the Aquarius root. Keep on drilling down. The next level is things are organized in directories by product time interval, as we discussed earlier. There's quite a few of those. And then the next level down, of course, is whether the product is a combined product or just the ascending and descending level 3 data. The next level down is then the time period, so the year, and then within that, the day-year directory for that data set. Okay. So once you finally drill down to the precise directory that you're interested in with the data that it contains, you then see a listing, and you have basically the various granules. Oops. Yeah, the various granules listed. And you can see there from our discussion previously, there's SSS, which is salinity, ancillary SST, density, and wind speed from the scatterometer. And you'll also notice that there's a second file that's similarly named for each of those categories with a .md5 extension. MD5 is not an actual data file. This is just a checksum file that ensures the integrity of the actual data file, which, as I said earlier, is BZ2 compressed. When you uncompress it, the data file is actually an HDF5 file. So anyway, when you click on one of those data files, you're then prompted by your browser to download the data set. So this is great using your web browser, but it's not the most efficient way of bulk downloading data files. And for doing something like that, you probably want to use a specialized FTP client tool I use a program called FileZilla that's available freely. And essentially what it allows you to do is simply by dragging and dropping from a remote FTP directory at any level, okay, you can just drag that across to your local destination directory, and it will automatically download all those granules in one go. So it's an efficient way of getting to the data and getting it onto your hard drive. Other features of this FileZilla tool is that it allows, you can do filtering of file names, so you can only download things that match certain regular expressions that you define for file names. And then it has a nice feature for managing the login information for various FTP sites. Okay. The final way that you can use FTP is essentially via your operating system command line. And I mention this here because if for those of you who want to get data on a routine and automated basis, you'll probably want to create scripts that run on cron jobs, that do scheduled downloading of data. And essentially FTP in combination with the mget command will allow you to do that. Okay? So essentially the syntax is given here. It's preceded with the anonymous login, and the password is simply your email address. Okay? And the screenshot just illustrates that sequence. Once you've actually gotten into the FTP site, you can then CD or navigate to the directory of choice. LS will list the directory items, and then you can begin downloading files. Now, if you're going to be downloading multiple files, you probably want to proceed with the command prompt N, which means that you're turning off the prompt that will otherwise come up every time a new file is getting ready to be downloaded. You have to press yes, Y, each time. So you want to avoid doing that. So by providing a prompt N command, it basically will automatically download all the BZ2 files that you specify with this command here. Okay? And again, you can use, here I'm using a wildcard to get everything in that directory, but you can apply other kind of filters in the file name filters in order to get the select items that you're interested in. Okay, so that covers FTP. I'm sure everyone is pretty much familiar with that. But in a way, it's not the most elegant way of accessing data and querying metadata as well, or doing subsets of data, because you have to, first of all, download potentially a time series of global data files. And say you're only interested in a particular region, you still need to download that data file and then extract the portion, the information, the portion that you're actually interested in to start working with it. So web services is an alternative and much more sophisticated way of accessing data, querying data, and downloading it. For those of you who may not be that familiar, a web service is essentially an application programming interface that can be accessed through standard web protocols such as HTTP to undertake some kind of operation on data. And that operation can be defined by a series of well-defined parameter extensions in that URL that's specified. And this is the general form that a web service request or URL will take. HTTP, as we said, the server that's being accessed, potentially a path to that web service, and then the particular web service accessed, and then the range of parameters defining your query. Okay, so that's the general form. And of course, the fact that it is an HTTP request means that you don't need any specialized software to execute this command. You can simply execute it, copy and paste the URL directly into any web browser, and it will execute from there. So the utility essentially, though, of web services is that it allows programmatic calls over the internet to a service via standard HTTP request it allows automated machine-to-machine data access and queries. Okay, you can request not only data or subsets of data or do some operation on the data and extract and download it, but you can also query metadata, okay, at the at either global or variable level metadata to return that as well. And essentially what you get back is some kind of data object. It could be an XML output, JSON output, a data file, or an image file. So increasingly more tools now, and this is a screenshot of the Live Access Server visualization and subsetting tool. Basically, at the back end, what you're doing when you make your GUI selections, okay, your selections on the user interface, on the back end, what is executing is actually a web service request. So, you know, you can essentially create client tools, such as LAS, that will be able to access data via these web services that PODAAC serves data through. Okay, so now let's look at some of these web service technologies that we support at the PODAAC. Probably one of the easiest to get to grips with, and perhaps one of the most useful for most users, is THREDDS. And THREDDS is a web service capability that's been developed to aggregate, serve, and allow subsetting of earth science data. Okay? Now, in THREDDS, one of the key aspects is this aggregation. Okay? You can create these catalogs, these THREDDS catalogs, that are logical aggregations of data sets and data granules. And the way we organize things at the PODAAC, okay, and this other data centers could organize things in different ways, but for a given data product, okay, of an entire time series of all granules for that data product constitute an aggregation catalog, okay? So here we see two URLs that you can click on. Actually, all of these, I'm not going to do it here because that would launch, you know, an application, the web browser. But when you download these slides, you can definitely try it out, and they will take you directly to the location on the PODAAC portal that hosts the Aquarius Salinity and Wind THREDDS catalogs. And this little screenshot here shows some output from what you would see when you click on the Aquarius Salinity catalog, okay? And you can see the different data products that we mentioned earlier, okay? And if you then click within one of these, this allows you then to get the entire time series of data that THREDDS is serving out for that particular collection. So one of the other advantages of THREDDS, in addition to dealing with these aggregations of granules, is that it allows subsetting of gridded data by value. That is with respect to latitude, longitude, and time. Okay, so you can specify those as query parameters. And in addition, even though the data may not be are natively in HDF, you can output them in different formats, such as NetCDF. So this slide just shows you, once you now click on that particular aggregation, okay, in this case, a 7-day salinity product from Aquarius, okay, what comes up is a form, okay, the NetCDF subset service, okay, form, where you can basically interactively specify a bounding box and a time period for which you want to query that catalog, okay? And what you'll get back is a single data file that aggregates all the results for that area of interest indicated by this screenshot, okay, for the entire time period. So you get back a really nice compact package that then you can work with, okay? So this is a graphical way of invoking a THREDDS query. But again, what underlies this web form is actually a web service request that looks like this, an extended URL that can be decomposed into, very understandable elements. There's the HTTP portion, request to the server, okay? There's the reference to the catalog, okay? Then you have after the question mark, you have the particular variable that's being queried, the variable list, and it could be more than one variable potentially, the bounding box filters, and then the time range that you want to specify in your query. So again, an example of querying by value that THREDDS makes very easy to undertake. Another type of web service technology for serving out and subsetting and delivering earth science data is OPeNDAP, and many of you may be familiar with it. It's a little bit more complicated to use because it is based on, it is index-based subsetting at the granular level. So for the user, you need to understand how the data is actually organized in data arrays so that you can specify index ranges to undertake a subsetting query, okay? And each of these operations works on individual granules. So in order to process a time series, you would have to submit a series of OPeNDAP requests for each granule in that time series. So this is an important distinction between OPeNDAP and THREDDS, and an example of why THREDDS for gridded data, okay, is a lot easier to use, for the uninitiated user. Okay. So anyway, for Aquarius, we have a link to where you can access all Aquarius data via OPeNDAP. Okay, by level, and Leslie explained some of this. Okay, so you can drill down ultimately, and then you get to the granule directory basically, and then there's a further step. You can click on that individual granule and expose metadata, okay, all the metadata, both global attributes and variable attributes associated with that data file, okay, and then you can basically download it in a couple of formats, or before downloading it, you can select to omit certain variables, and it's hard to see, but there are these little dialog boxes here where you can specify array ranges, okay, that you want your extract to include. So by default, okay, this is the entire data array, but you can go in here and say, look, I'm only interested in certain latitudes and certain longitudes, and I want to skip every second grid point, okay, by the step parameter here. So then you can specify that. The query then appears in this URL box, and you can copy and paste it somewhere else. Or you can just then execute that query with the subsetting invoked and get just that exact portion of the data file for your region of interest, okay, if you're working on a regional study. Again, this is the form, but what is going on the back end is a OPeNDAP web service request, again, with this sort of extended URL. And again, it's very straightforward to understand the structure of this. Once you've looked at a couple of these things, you'll get the hang of it. So essentially, again, there's the HTTP request to the OPeNDAP server at PODAAC, okay? Pointers to the particular granule. Again, OPeNDAP works at the granule level, okay? And then you can see here that you can specify an output format for the extracted data that you're going to get. After the question mark, the variable list, in this case only one variable, the L3M data array, and then the portion of the data array that you want to subset. As you can see, I'm not taking the data array in its entirety. So that's it for OPeNDAP. The final web service that I just wanted to point out very quickly is a range of web services developed at PODAAC for querying metadata, okay, in our catalog database. And this is both granule and dataset level metadata. You can get at any of that, okay? there's essentially a range of commands that are available, and again, a web form that will illustrate how that web service is invoked. And this slide here just demonstrates how you can chain a series of these web service calls to use then the output of an initial request and feed that into a subsequent web service request where you get more detailed information. So later on you can study this workflow if you like and actually try it out, and it will show you how you can get from querying just the keyword based, an Aquarius keyword. This first operation effectively emulates exactly what we did on previously on the web portal, right? When I queried for Aquarius and got the listing of data sets, this is exactly what's executed on the back end, and you get a listing of these files. So you can continue through this chain and then see how you can get to very detailed information on even Aquarius data files. And so this is my last slide, and I won't really, I'll let you guys study it on your own when you in your own time. But it basically summarizes what these various web service capabilities do, their pros and cons, their ease of use. Okay, so depending on specifically what you want to do, your level of technical expertise and comfort, you may want to use this as a guide to which web service to use. And that's about it for my presentation.